and I'll be presenting what is tentatively known as the Astraea project. In this film, I shall summarize what the project is creating, what our goals are, and showcasing some of the developments that have been made since its beginning. As a quick note, throughout this video, I will be inserting extra little footnotes and bonus facts that either I forgot to mention while recording, or to provide extra context for what I'm saying right now. So if you need to pause or rewatch the video again at a later time to reread through them, feel free to do so. So first off, allow me to answer the question you've probably had on your mind since pressing play. The Astraea project is a speculative biology and world-building project centered around an alien planet known as Astraea. The planet is considerably Earth-like and has carbon-based organisms that have since developed in the habitable zone of its star. Over time, these organisms will diversify and radiate into numerous other forms as they adapt to their changing environment and create a full-fledged biosphere together. Now, many might feel tempted to compare this premise to Bilbidarian's Alien Biospheres video, or to the more popular Alien Planet of Wayne Barlow's expedition, but this project has a very different end goal in mind. The Astraea project is an experiment to create a viable, feasible world using the established laws of astronomy, geology, chemistry, and biology. One of the main purposes of this project has been to explore how each of these fields of study interact and correlate to one another, and explore how they work together to create the vast and beautiful world that we live in today. If you're only interested in SpecEvo to see cool monsters with crazy powers, first off, you're awesome and I love you, but you're probably not going to be interested in this project. This isn't about making creatures, this is about finding connections. This is the kind of project for those folks who watch movies with the director's commentary on. If you're someone who likes to take things apart to learn how they work so you can better appreciate how they all come together, then this is the kind of thing you might be interested in. So now that I have given you a brief overview of the project and its goals, let me give you a brief tour. The Astraea project centers around a binary solar system known as Eos. There are two stars in the system, a KV-class orange dwarf and an M-class red dwarf. Eos A has 4 planets which orbit it. They are Keone, Themis, the only gas giant in the system, Dike, and Astraea. The closest planet in is Astraea itself. The planet is tectonically active and experiences tides which are 2.5 times greater than Earth, thanks to its moon Nepta, which despite its smaller size, orbits much closer by comparison. The only key differences between the environment on Earth and the environment on Astraea are the star it orbits and the specific pathway life on Astraea has taken to get to where it is. So let's cover that next. Astraea formed roughly 5 to 6 billion years ago from the collisions of several large planetoids. As the planet cooled down, water vapor began to outgas, forming the first oceans. It's unclear when exactly life first emerged, but the confirmed records of life date back to 3 billion years ago. These early prokaryotic microorganisms thrived around chemical gradients not too dissimilar to extremophile life forms on Earth. For the first several millennia, these microorganisms diversified and spread across the surface of the world, specializing for chemotrophic and heterotrophic niches. Roughly 2.5 billion years ago, though, a revolutionary mutation occurred, resulting in the first photosynthetic microorganisms. Some of the earliest of these phototrophs even began to form colonies visible to the naked eye, fusing their silicate cell walls together to create the eerily glass-like structures known as splenidomites, a similar colonial form to Terran stromatolites. The proliferation of these colonies, though, caused a massive rise in atmospheric oxygen, bringing about Astraea's first mass extinction event, Snowball Astraea, a global glaciation where ice sheets over a kilometer thick spread from pole to pole. This global ice sheet, though, allowed carbon dioxide from geologic processes to build back up in the atmosphere, triggering a massive instance of global warming, which melted the ice and caused the formation of massive cyclonic storm systems for millions of years. These super hurricanes churned the seas, which released more oxygen in the atmosphere, and over the next billion years, the climate went through a back and forth period of cooling and warming, gradually stabilizing to levels comparable to early Earth. While the atmosphere's gases balanced out and the storms ravaged the world, sediments from inland were washed into the ocean along the first rivers. This influx of oxygen and fresh nutrients from inland allowed the oceanic microorganisms to flourish and develop themselves much quicker than before, resulting in a new wave of biological diversification.
some microorganisms began to form partnerships by means of a process called endosymbiosis, which resulted in the creation of the first eukaryotic cells. With these new specialized unicellular microorganisms evolving, the first true ecosystems and biospheres gradually bloomed in Astraea's seas. As the ages passed, these microbes began to proliferate and further enhance themselves, gradually clustering to form colonies, tissues, and eventually fully multicellular life forms. These metazoans quickly formed some of the most numerous species on the planet, dominating the scum-covered seabed of the Eurodokian period. But now a new age has dawned. In the chaotic seas of the Enedrian period, new biological advancements have swept the world, prompting an arms race between life forms, the likes of which has never happened before and will likely never happen again. This explosion of biodiversity will shape the course of life on Astraea for millions of years.
And let me check. We have 7 minutes left. Okay. Well, since I have a little bit more time, I guess I'll give you an overview of some of the creatures in the project. Before we describe the creatures of the Enedrian, it is important to recognize how we as Terrans organize life. On Earth, there are 3 commonly known forms of life. There are plants, which use sunlight to obtain energy, animals, which move around and eat organic matter, and fungi, which break down that organic matter as decomposers. Most of these organisms remain locked to their respective ecological roles as producers, consumers, and decomposers. So we naturally tend to compare other life forms to these groups. On Astraea, though, all the ecological roles have been occupied by animal-like organisms to such a degree that every macroscopic life form on Astraea is something similar to an animal. To better explain this, let's start from a familiar basis. This creature is the newt sloop, Astraea's first super predator. It's only about the size of a house cat, but in the Enedrian, that's still pretty enormous compared to its prey. The newt sloop is a descendant of a mollusk-like organism known as the taco slug, and they swim by undulating a pair of fins that stretch down both sides of the body, similar to the extinct radiodonts, or even to modern swimming sea slugs. It has an extendable rostrum, or proboscis, which it uses to grab onto its prey and pull it back towards its mouth, where it will use its radula to bore into the prey, eating it alive. This is pretty standard for what one might expect animals to look and act like, but other organisms are a little bit stranger. This creature, half buried in the seabed, looks almost like an overgrown sea urchin. But this creature, called the goggle grub, is, in truth, Astraea's earliest version of plant. While true plants do exist on Astraea, they are primarily consigned to microscopic organisms like algae. In the wake of the snowball event, they decided to partner with these organisms to ensure that both organisms can live in a stable environment, in a stable niche. The secret lies in the spines of the goggle grub. Clustered within special hollows within the spines are Athesian algae, which have taken residence inside the grub's body, sharing a portion of the nutrients that they create with their host as they photosynthesize, and in return, the goggle grub ensures that its algal symbiotes are protected within its armored spiny body. The grubs even nurture the algae and share a portion of the nutrients they obtain from feeding on detritus on the seabed. This adult grub, however, is grown so heavy that it now almost exclusively relies on its algae for food. It'll only move to feed its algae or find a new patch of ground to settle into. Now, also scattered across the seafloor are various species of jelly shrooms. These cnidarian-like organisms, despite their varied appearances, have remained comparatively unchanged for the past 50 million years. These organisms are Astraea's curious comparison to fungi. The single most recognizable trait of Terran fungi is the mycelium, a root-like collection of cellular fibers which the fungus uses to interact with its surroundings. The mushroom is the most recognizable part of the fungus, but the majority of its body is actually the mycelium. The tricky thing comparing fungi to animals is that the mycelium largely operates on a microscopic scale. Each individual fungus cell operates as part of a much larger superorganism. Jelly shrooms do operate fairly similarly, though. All jelly shrooms begin life as free-swimming larvae, drifting in the currents, seeking chemical scents, which will lead them to fresh food. They'll seek out anything from patches of algae to fresh carcasses, and once they find a source of nutrition, they settle in, they latch on with their little tendrils. From there, the individual will begin to burrow in, growing its tendrils like roots throughout the anchor point, digesting what it can, and feeding its growth. This rooted form is the form that the jelly shroom will spend most of its adult life as, a tangled network of root-like tentacles radiating outwards and downwards from a central mass. When it's time to reproduce, it metamorphoses into the familiar shape of a polyp, where it fertilizes and grows the next generation to be released en masse. So these three kingdoms of organisms, regular animals, plantimals, I guess we could call them, and jelly shrooms, have grown to dominate all the macroscopic niches on Astraea's oceans. But like I said, this is still a very experimental time. We're still in the middle of the explosion here. New species are evolving faster than they ever have before or ever will again. Whatever shape life on Astraea will take, it's still yet to be determined. And that is where the project is currently at, in a period of time roughly analogous to the Cambrian explosion. We do have plans to include future mass extinction events, moving on to land, and of course creating a finished tectonic history of the most recent billion years of the planet's existence. Despite the focus on science, I also want this to be a creative project, so another goal is to find artistic ways to depict the world of the project. This also aims to include storytelling, music, even a project encyclopedia with written entries describing every aspect from tectonic history to phylogenetic tree. So yeah, that's an overview of where the project is at. Again, I'd like to thank you all for watching this video. Shout out to my friend Eggman, whose fantastic art concepts and imagination has really helped inspire much of the life forms you've seen today. Without him, the project wouldn't have gotten nearly as far as it has, so if you're watching this, Eggman, thanks a ton. Special thanks to Dynaboy Studios for agreeing to host this project. And again, thanks to you for sitting through this for a good however long this is right now at this point. So yeah, I don't think I'll make regular updates on this just because it takes a really long time to update it at all. But yeah, so bye.